Welcome to part 2 of an introduction to the derivative. In this example, we're going to want to take the derivative of this function, and we're still using the limit definition of a derivative. So let's begin. So the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x, and now we substitute x plus delta x wherever there's an x, so we have x plus delta x cubed plus 2 times x plus delta x minus x cubed plus 2x all over delta x. Now we have a binomial expansion to the third degree. In case you need help with that, check out the information on binomial expansions, but it's not all that hard. The coefficients are going to be 1, 3, 3, 1, and we have x to the third, x squared, x to the 0, and then delta x to the third, delta x squared, and then delta x, and then they're just plus, and then we put in our expansion here, so we're going to distribute the 2 here, so plus 2x plus 2 delta x minus this, so negative 1 times x cubed is negative x cubed. Negative 1 times 2x is negative 2x. All over delta x. Okay, now we should have cancellations that get rid of everything but delta x terms. So this and this cancel out. This 2x and this 2x cancel out. So now we have 3x squared delta x. And you have to be careful here because it's real easy to make a trip up on something simple. Plus 3x delta x squared plus delta x cubed plus 2 delta x, and that's it, all over delta x. Now let's see if we can cancel out some delta x terms here. So this delta x goes with this one of these, and that one. So we have 3x squared plus 3x delta x plus delta x squared plus 2. So the delta x in the bottom is gone. So now here we're going to take our limit. So let's move this down. And the limit as delta x goes to 0 of this whole thing, this term goes to 0, this term goes to 0, and what we're left with is 3x squared plus 2. This function will generate the slope of the tangent line of this function at any x value on this function's domain. And let's move on to another example. In this example, our function is the square root of x, and we want to find f prime of x, which is the first derivative of this function with respect to x, at the points 1, 1 and 4, 2. So let's begin. Limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x, which gives us the square root of x plus delta x minus square root of x all over delta x. To evaluate this limit, we're going to have a problem, because as you can see with this delta x in the denominator, we can't evaluate this limit directly. You remember your discussion on limits. To evaluate this limit directly, this limit would go to infinity because the denominator would go to 0. Now, in our previous examples, we were able to get rid of this problem by doing cancellations. But in this situation, we don't have anything readily apparent that will allow us to do that. But fortunately, we have an algebraic technique we can employ that'll give us a hand in this process. So we're going to be able to eliminate this delta x by doing some algebraic manipulation. And what it relates to is this radical up in the numerator. We're going to multiply the numerator and denominator by a form of 1 that includes the conjugate of this. So what we're going to do is we're going to multiply the numerator by the square root of x plus delta x plus square root of x divided by the same thing, the square root of x plus delta x plus square root of x. And when we multiply these out, hopefully that'll get rid of this problem in the denominator. So let's begin. We're actually going to multiply this quantity by that quantity. So this times this, the square root of anything squared is the thing itself. So the square root of x plus delta x times the square root of x plus delta x is just x plus delta x. This times this gives us plus the square root of x plus delta x times the square root of x minus this minus the square root of x times the square root of x plus delta x. This times this minus x. So the square root of x times the square root of x is the square root of x squared, which is just x. And now in the denominator, we're just going to leave these terms the way they are. It's going to be delta x times the square root of x plus delta x plus square root of x. Okay. Now, let's see if this did what we hoped it would do. This term and this term cancel out, because this is the positive version of this. So this and this go away. And you can see we have an x and a negative x here. So the negative x cancels out the x. So what we're left with in the numerator is delta x. So delta x over delta x times the square root of x plus delta x plus square root of x. And now you can see that the delta x's in fact cancel out, and what we're left with is 1 over the square root of x plus delta x plus the square root of x. And here's where we're going to take our limit. As we take our limit as delta x approaches 0, this term goes to 0, and we have 1 over square root of x plus the square root of x, which is 1 over 2 square roots of x. And that's our derivative. Now, we're looking for the derivative at 1, 1. So, we're going to substitute a 1 in for x here, and we have, so at 1, 1, 1 over 2 times the square root of 1 is just 1/2. And then at 4, 2, so at 4, 2, we have 1 over times the square root of 4, which is, square root of 4 is just 2, so 1 over 2 times 2 is 1 over 4. And there is our slope of the tangent line of the function square root of x at 1, 1 and 4, 2. Before we leave this example, I want to investigate a little result of this that's very, very important. If we take a look at the graph of the function of square root of x, and we look at it from the standpoint of the derivative, 1 over 2 square roots of x, what happens to this derivative at the point 0, 0? Well, we can see when we put a 0 in here, we have 2 times 0, and this limit is not defined. This limit function is not defined. Now that's going to be a very important consequence of derivatives, that when we take the derivative of a function, we're not guaranteed that that derivative is going to exist at that point. And that's going to be the subject of a bit of discussion as we move forward. So it's clear, since this function has a vertical tangent line at the point 0, 0, the derivative is undefined. So let's move on to another example.